This was extremely important because Brenda Milner had discovered a specific location. She showed that the hippocampus and the medial temporal lobe are absolutely essential for converting short-term to long-term memory. For many years, a period of over 10 years, Brenda Milner thought that this applied to all areas of knowledge, that everything that H.M. learned in short-term memory, he could not convert into long-term memory. And then she made another fantastic discovery. She gave a terrific lecture at the Society of Neuroscience meeting 2 weeks ago in which she said this was the most exciting moment of a scientific career. She found that, in fact, there were certain areas of knowledge in which H.M. could convert short-term to long-term memory. And that is, he could learn certain motor tasks. And some of you have performed these tasks. She had him do a mirror drawing task. And that's a situation in which you have to draw the outlines of a star by looking neither at the star or your hand or the pencil, but looking only at the mirror because you cannot see the star or your hand. This is the apparatus. Many of you have used that. Other of you that have not had a chance to do so could do so later on outside. She found that when H.M. did this, he made a number of mistakes the first day, but improved over 10 trials. The second day started off better and got better still, and the third day, perfect. This is as good as you can do. In fact, this is one of the students in this group. Lots of mistakes at the beginning, perfect afterwards, and this is the average data for a whole bunch of students here. You people are as good as H.M. I'm going to tell your parents that you've got a terrific memory. But there's one fantastic difference between you and H.M. You remember what you did the previous day, and you remember how you progressed from day to day. So you understand you did better on Wednesday than you did on Monday because you did 10 trials a day each of those 3 days. But when you asked H.M., how come you're doing better on Wednesday than you did on Monday, he would say, what are you talking about? I've never done this before in my life. He was completely unaware that he was doing this. So Brenda Milner discovered what we now know to be a large area of mental life in which memory is stored in an unconscious way. So this made us realize that their memory storage is not a unitary faculty of mind, that there are at least 2 major kinds of memory processes that are stored at different sites and use different logic. They're called explicit and implicit, respectively. Explicit memory is a memory for facts and events, for people, places, and objects. They involve the hippocampus and the medial temporal lobe. You take those out, you lose this, and it requires conscious recall. So if you ask yourself, what was it like on the first date? You make a conscious effort to recall that. If you think about your last birthday, a conscious effort to recall that. How to get back home, this requires a conscious effort to recall that. Everything that is stored in explicit memory that is hippocampal-based requires conscious effort to recall. By contrast, we all master a large number of motor and perceptual skills that once they're mastered, become completely unconscious. These are stored in a number of structures, in the amygdala for emotional memory, in cerebellum for motor memory, and in the simplest reflex pathways, which Tom and I are going to consider in later lectures. These allow you to store modifications of reflex strength, various motor skills, or emotional things. And when you recall these, it's an unconscious effort. Let me give you an example. When you first learn how to ride a bicycle, you tell yourself, put your left foot forward, put your right foot forward. Once you learn to ride the bicycle, you don't talk to yourself. If you talk to yourself, you fall off the bicycle. When you rush to the net in order to hit a backhand, you don't tell yourself, get your shoulder around. You do this automatically, or you're lost to begin with. What is amazing, what is absolutely amazing is how much of explicit memory, once it's mastered, moves into implicit memory because it's more efficient. I am to this day amazed how much is carried out in memory implicitly. Some of the most remarkable creative skills, after a while, move into implicit memory. Let me show you what I think is an extraordinary example. This is Clive Wery.
Clive Wearing has one of the worst cases of amnesia in the world.
I know it's like to be dead now. Day and night the same, blank. No difference between dreams and anything like that, no senses at all. The brain has been totally inactive. No dreams and no thoughts of any kind whatever.
Clive was a renowned conductor living in London when he was struck down by a virus in 1985. Parts of his brain were completely destroyed, including his memory. However, his ability to play music is unaffected.
Do you feel different when you play music?
I've never heard a note since I've been ill. I don't know what it's like to play music when you're unconscious.
You played us some music about 2 minutes ago.
Not known to me. Totally unknown. I've never heard a note yet.
Let me step back and summarize what we've covered so far. We began by asking, can any mental process be localized to specific regions of the brain? And we saw that the answer was yes. But it's not a simple view. It's not that mental processes are localized to single regions in the brain. They involve the Wernicke scheme. They involve several areas that are precisely interconnected. And we're going to hear more about that in the subsequent lectures. We then asked the question, can memory specifically be localized to regions of the brain? And again, the answer was yes. And again, the result is sophisticated. There are different kinds of memory storage, explicit and implicit. They're stored in different areas. One, hippocampus and medial temporal lobe. The other, amygdala, cerebellum, and reflex pathways. Clearly, we next want to know, and several of the questions already directed our attention to this, how do these regions that are involved in memory storage, how do they develop? How do they come to represent memory? And we're going to learn about that in the next couple of lectures, so please stay tuned to what Tom Jessel will have to say to you. Before we end this lecture, I'd be delighted to have some questions from you and see if I can answer them. Yes?
You said that the implicit mind is also responsible for emotional responses. I was wondering if HM was able to show any capabilities with emotional responses.
Yes, he does show. For example, if you show him frightening images, he shows an increase in heart rate. Patients like this will show this. William James was the first one to point out that they're both unconscious and conscious components to it. And it's very interesting with fear. For example, when you see a tiger approaching you, unlikely to happen at the HHMI headquarters, but let's assume for a moment it does, your heart rate increases and you begin to make preparations to escape before you fully realize consciously that it's a specific kind of animal that is attacking you. So you see, you identify danger qua danger before you identified consciously as a specific source of that. Sir?
What sort of roles do stem cells play in acquiring memory, specifically implicit?
This is a very interesting topic. There are stem cells in the hippocampus that continue to divide throughout much of life. They decrease as animals get older. And their role at the moment in memory storage is unclear. It's a bit controversial. So if you irradiate this region and selectively knock out those cells, lots of memory tasks, hippocampal-dependent memory tasks, are intact.